Hi, in this video, we'll try to see how to use the analog to digital converter of Raspberry Pi Pico to achieve some simple project or to achieve a physical quantity being sensed. But we don't want to do that with any fancy sensor. But instead, we want to achieve that simply using something as simple as an LDR or a light dependent resistor. So, let's get started. Now, LDR or a light dependent resistor is a very interesting yet simple component. It simply changes its resistance based on the amount of light falling onto it. Most LDRs will show or will demonstrate an increase in the resistance that they offer when there is darkness onto the surface of LDR or when it senses darkness or when it senses less light. And as you keep giving it more light, then it will show or it will reflect lesser resistance. Now, this is a change in electrical parameter. Okay, this is not an actual value of voltage given to you. But it's our job as designer, as engineer, as technician to convert this change of resistance into change of voltage. How to do that? It's very simple. All you need to do is you need to have or you need to create a potential divider with LDR and resistor. To do that, all you are going to need are two components. One is an LDR itself, and then the second one is a very simple resistor. Let me show you the LDR first. My camera, yes, it's there. Now this is my multimeter. I have set it onto the resistance measurement tab, and I'll just show you. This is LDR. Okay. Now I'll try to measure the resistance between the two leads of LDR, and if you can see, in full light, it's reading somewhere close to 1 ohm. If I give some darkness to it with the shadow of my hand, it's 3.3 ohm. If I just touch it, full dark, 27 point something ohm, kilo ohm, sorry, all the readouts are in kilo ohm. My multimeter is set to 200 K range. Okay, so starts from 1 kilo and then ends at 27 or even 30-40. Now this 1 kilo ohm will reduce furthermore if you simply apply a torch light onto the top of it. So this is your LDR. I'm going to insert LDR. So what I'll do is I will try to create a small potential divider circuit here. So this is the LDR. All I need is a 10K resistor, brown, black, orange. So this is the second point of the resistor, and I'll simply connect it to some other place. Now what we need to do is give one point of this circuit, let's say this one, to VCC and the last point to ground. So I'll just give this one wire here, the other wire over here. So ground is easy to identify, third from top. VCC is also easy to identify, one point after that. Pin number 26 is, I guess, something I will always count. 31, pin number 31, that is GP26. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 and 31. And this should go to the intersection of this resistor and LDR, just right here. We are done with the connections needed. Now I'll just keep this at one place. I want nothing but the same code that was done in the previous exercise for ADC's testing. Let's close it, clear it, and then let's run it. This time I'm not that much interested into voltage, so I'll just comment this line for now. A simple ADC number is sufficient for me. Can you see 53,789 or something close to that? That's the number that you are experiencing or getting. Now what I'm going to do, I'm going to bring some shadow or darkness onto the LDR. Can you see? The reading has now gone to 30,000, 135, 32,000 something. Let's bring further more darkness, just a window where you can see that. Now as you can see, it is 20,000, 420, something like that. What is happening? Basically the voltage is reducing. I'm not going to go into the properties of potential divider and how I have set it. I guess everyone will understand that. The change is, if I swap the voltage and ground connection, then I will get a reverse experience. So currently with darkness, my voltage is reducing. If the configuration is opposite, with darkness, the voltage will increase. Now on the contrary, I would also like to make one more experiment. This is a tube light behavior where it's observing or giving good amount of resistor. What I want to do is, I want to use this, a torch from my phone, and I'll just try to put it gradually. Now if you see, when I give torch, the reading increased because now it's giving full light, and in full light it offers very less resistance, thereby giving the entire 3.3 volts to appear across resistor, and we are reading almost 60,000 something as a readout. Now you can easily convert this project into checking of a relay. You just set a threshold for yourself with this value. If the value is less than this particular threshold, it means it's dark, you need to turn on light. If the value is more than a particular threshold, it means it's light or sufficient ambient light, and all you need to do is turn off your device. Try to do that as an exercise for yourself and see how it works. The components were simple, the connections were simple. Yeah, breadboard and connecting wires. That's something I'm not telling you in each experiment because I guess you know it. I just put a finger onto it for the fun of it, and you can see the value is reduced drastically. What it does mean is it offers so high resistance that very less voltage appears or very less current passes through the LDR. So apparently the voltage across resistor is very low that we are measuring. That's it for the LDR experiment. Thank you for watching.